Good evening, people. And I think we had a very good revision in current and magnetic effect of current. And for the simple test I gave you, your doubts would be most welcome, and we would discuss them on Thursday and Friday. I hope you get it, so that your Saturday you can keep revising. Now at least you know there is the grand test on Saturday. I would mark the syllabus today. And today I'm going to start with a new unit which is also very interesting. In these 3 days मीठा मीठा कर लेंगे, पर syllabus आपके grand test का वो ही रखेंगे, current electricity and magnetic effect of current. जो कुछ आपका पिछली बारी अच्छी तरह नहीं तैयार हुआ था उसे तैयार कर लेना, देखना फायदा बहुत होगा. Let me start with the new unit today, please. Electromagnetic induction. Please see कि ये करने के बाद फिर रिवीजन करना. इलेक्ट्रोमैग्नेटिक इंडक्शन के नोट्स में किसी के भी मंगवा सकता हूँ. Electromagnetic induction. Simply put, I will call it EMI. थ्योरी काफी लिखूंगा. The phenomena of inducing just a minute. Okay, the phenomena of inducing electricity from magnetism. The phenomena of inducing electricity from magnetism. What we have done in the previous lesson is that we have attributed any kind of magnetism to an electric current. जबकि अर्थ magnetism भी हमने किसी न किसी करंट को attribute किया है. Any kind of, even the magnetism of a bar magnet is due to a current which is produced due to the electron revolving around the nucleus of an atom, and so on. Now it's just the reverse. The word induced means that it is only for a certain time and will vanish after that condition goes. So here we are going to produce, rather induce, electricity from magnetism. And we are going to start with an experiment. We started the previous unit with the Oersted experiment. We are here going to start with Faraday's experiment. Faraday's experiment. Faraday ने क्या किया कि he took a coil and he attached a galvanometer with it. He took a magnet. Now there's no source. सोर्स के लिए हमें कोई ना कोई सेल या बैटरी लगी होनी चाहिए. यहाँ कोई बैटरी नहीं लगी है. We just have a galvanometer attached. He took a magnet and tried to move the magnet towards the coil. Now, what did he observe? He observed that there was a deflection in the galvanometer when the magnet is moving with respect to the coil. Observations. Let's write the observations here. पहले बात सिर्फ ये थी कि मैं सिर्फ बोलता था और आप लिख लेते थे. अब मेरे को लिखना पड़ रहा है. चलो साथ साथ आप भी लिख सकते हो. पहली observation. Whenever there is a relative motion between the magnet and the coil, the galvanometer shows a deflection. क्या हुआ? It's a very interesting story. कि Faraday was thoroughly convinced कि we can definitely produce electricity from magnetism, because scientists जो होते हैं ना, वो reverse theory में बहुत believe करते हैं that if there is magnetism due to a current, then there will definitely be a current due to magnetism. He was totally convinced, but he did not know how to go about it. What he did was he took a coil and took a magnet, and he just placed the magnet left, right, above, below, center, inside the coil. He just was placing the magnet in and around the coil and even inside it, but he did not see a deflection in the galvanometer. He repeated the experiment a number of times at different places, and then one day, out of desperation, he threw the magnet into the coil, and voila, he observed a deflection. He took the magnet and moved it slowly towards the magnet. He took the magnet and moved it slowly towards the coil. There was a deflection, but the deflection lasted only for the time the magnet was moving. The moment the magnet was brought to rest, this deflection vanished. साइड पे हो जाता हूँ, लिखना भी होता है। और क्या उसने ऑब्जर्व किया? चलो पहले मैं बता देता हूँ, मैं फिर लिखूंगा। When you reverse the direction of motion of the magnet, this direction of deflection was also reversed. When he moved the magnet towards or away from the coil, the deflection was more. This means that the rate at which the magnet is brought towards or away from the coil will determine the amount of current which has been induced. When the magnet is at rest with respect to the coil, there was no deflection, please. No, यहाँ से explain करता हूँ. Now, I think you are unable to see me, but you are able to see the board very, very clearly, so that you can write things. I will be right back to you. Faraday's experiment, there is a coil attached to a galvanometer. Now, a galvanometer is a very sensitive instrument. It can detect even a very small amount of current. When the magnet is moved towards or away from the coil, there is a deflection in the galvanometer. Right? The deflection in the galvanometer is reversed. दो तरीके से reverse होगी. दूसरी बात, the deflection in the galvanometer is reversed when, number one, direction of motion of the magnet is reversed. B, polarity of the magnet is reversed. दूसरी बात, there is no deflection. चलो वो लिखने की जरूरत नहीं है. There is a relative motion between the magnet and the coil. ऐसा भी हो सकता है कि magnet rest पे है और coil move कर रहा है. When the magnet is at rest with respect to the coil, there is no deflection. ये मैं लिख नहीं रहा, obviously. The deflection is directly proportional to, right? साथ साथ लिख रहे हो ना, नोट्स बनाइए और साथ साथ, is directly proportional to the rate at which the magnet is moving. which I can explain once again is, we are trying to induce electricity from magnetism, and Faraday did a small experiment in which he was able to prove that definitely we can have electricity from magnetism. Whenever there is a relative motion between the magnet and the coil, the galvanometer shows a deflection. This shows that there is some current and an EMF induced in the coil. When the magnet is at rest with respect to the coil, there is no deflection. The deflection in the galvanometer is reversed when the direction of motion of the magnet is reversed. ये नॉर्थ पोल पहले यहाँ आ रहा था, अब नॉर्थ पोल परे जा रहा है, यही वाला North pole approaching the magnet, North pole going away. When the polarity of the magnet is reversed, if instead of the North pole approaching the coil, we approach the South pole. पहले North pole नीचे आ रहा है, अब South pole नीचे आ रहा है, तो deflection reverse हो जाती है. You can copy it down, I think. मैं रख कर दूँगा फिर आपके पास. अब यहां पे कोई जादूगिरी तो हो नहीं रही है. कॉज ऑफ इंड्यूस्ड ईएमएफ, कॉज ऑफ इंड्यूस्ड ईएमएफ. देखो ना, किसी ना किसी तरीके से तो इलेक्ट्रॉन की मूवमेंट इनिशिएट हो रही है, राइट, विच इज गोइंग टू कॉज अ करंट. कॉज ऑफ इंड्यूस्ड ईएमएफ, ये देखा गया whenever the magnet is moved towards or away from the coil, ऐसी क्या चीज है जो कि चेंज होती है. Whenever the magnet is moved towards the coil, the magnetic flux linked with it increases, and whenever the magnet is moved away from the coil, the magnetic flux linked with it decreases. Now, what is magnetic flux? Magnetic flux is basically the number of magnetic field lines which are intersecting a given surface. The strength of the magnet is more closer to the field, closer to the poles. Thus, the number of field lines which would be passing through would be more. It is the cause of induced EMF. Whenever the magnet is moved towards or away from the coil, whenever the magnet is moved towards or away from the coil, the magnetic flux sorry, अच्छा लैंग्वेज थोड़ी चेंज करते हैं. Whenever the magnet is moved towards or away from the coil, there is an increase or decrease in the magnetic flux. Linked with the coil. Whenever the magnet is moved towards or away from the coil, there is an increase or decrease in the magnetic flux linked with the coil. And it is this changing flux and not its mere presence which is responsible for the EMF induced. Boom. I just draw a small picture of the linkage of magnetic flux. There is going to be a lot of mathematics also, but the physical part to be understood is going to be very, very interesting and very, very important. सारा कुछ conceptual रहेगा. Let's say we have this magnet here. North, south. These are the number of magnetic field lines which are emanating from it. So it is obvious that if I have an area here, then the same area is here. I hope you understand now. No? Okay, I have an area here and I have an area here. The number of field lines which are passing through this area are lesser than the number of field lines which are passing through this area. Right? These are the field lines which are emanating from the North Pole. Thus the magnetic flux. बड़े अच्छी तरह शो हो गया. Thus the magnetic flux linked with this area here is definitely more than the magnetic flux linked with the area here. If the magnet is close to the coil, the number of magnetic field lines which would be passing, which would be intersecting through a surface are going to be more. Thus, whenever the magnet is moved towards or away from the coil, there is a towards आएगा तो increase हो, away जाएगा तो decrease हो. Thus, whenever the magnet is moved towards or away from the coil, there is a change in the magnetic flux. Increase or decrease, there is a change in the magnetic flux linked with the coil. It is this change in flux and not its mere presence which is responsible for the induced EMF or current. ज़्यादा फ्लक्स हो, ऐसे तो मैग्नेट को आप कॉइल के बीच में रख दो, रेस्ट पे. No deflection in the galvanometer. At that time, the magnetic flux linked with it is maximum, but there is no deflection in the galvanometer. So please see, it is the change in the magnetic flux which is responsible for induced EMF or current. एक नोट डालो, मैग्नेटिक फ्लक्स क्या होती है? Magnetic flux. It is the measure of number of magnetic field lines intersecting a given surface. Just as electric flux. ये सपोज करो मेरे पास सरफेस एरिया, तीन केसेस बनाऊंगा and this is the surface area vector. Magnetic field normal to the surface. So number of field lines intersecting the surface are maximum. B normal to surface. If the field is normal to the surface, the angle between the magnetic field and the surface area vector is zero. Maximum flux. Magnetic field tangential to the surface flux zero. क्योंकि कोई भी मैग्नेटिक फील्ड लाइन इसको इंटरसेक्ट नहीं करती. मैग्नेटिक फील्ड एट एन एंगल. इसके दो कंपोनेंट बनेंगे, एक नॉर्मल, एक टेंजेंशियल. Only the normal component of the magnetic field will contribute to the magnetic flux. Therefore, magnetic flux through the surface ds is given by d phi. m डाल देते हैं थोड़ा सा, मैग्नेटिक फ्लक्स है, is b cos theta into ds, या फिर d phi m will be b dot ds. The total magnetic flux through a given surface is phi m. ये सारा सारेगा ये आ जाएगा. The total magnetic flux through a given surface. हाँ, the total magnetic flux for a closed surface is always equal to zero, because the total number of field lines entering it and leaving it would be the same. But if we have a given surface which is not closed, उसमें से magnetic flux जरूर होगी. If B is uniform and normal to the surface, तो जो phi m है simply B into A आ जाएगा. I hope it is clear. B into A क्यों आएगा? जनरल डिस्कशन है बेटे, क्योंकि B D is cos 0, B बाहर आ गया, इंटीग्रल ऑफ ds s, which is the total surface area, जिसको मैंने A total surface area. If the field is normal to the surface, मैथमेटिकली हो गया ना, ये फिजिकली समझाया. If B is normal, if B is tangential to the surface, if B is uniform and normal to the surface, theta 0. If B is tangential to the surface, theta is 90, giving me phi to be 0. And if it is at an angle, तो हमें the physical and the mathematics of magnetic flux. Please visualize This is called the surface integral of the magnetic field. The surface integral of the magnetic field denotes magnetic flux. Thus, whenever the magnet is moved towards or away from the coil, the magnetic flux linked with the coil changes. It is the change in magnetic flux and not its mere presence which is responsible for induced EMF or current. बड़ी सिंपल सी मीठी मीठी सी चीज शुरू करेंगे. 3 दिन ही लगाने हैं. मैंने सिर्फ थर्सडे फ्राइडे को आपका रिवीजन टाइम होगा, वहां मैं आपके डाउट्स कंसीडर कर लूंगा. सैटरडे को आपका टेस्ट है, a grand test. Those of you who are prepared nicely for it must take it. ना ये सारी कहानी इकट्ठी करके हमने बना दिए फैराडेज. अच्छा, यूनिट्स बनाते हैं मैग्नेटिक फ्लक्स के यूनिट्स ऑफ मैग्नेटिक फ्लक्स. ये छोटी छोटी चीजें ना रह जाती हैं. phi m with b into a, तो क्या आएगा जी? टेस्ला मीटर स्क्वायर, which is called 1 Weber. That is why magnetic field के unit Weber per meter square लेते हैं. Therefore, 1 Tesla is 1 Weber per meter square. Basically, magnetic flux के unit Weber होते हैं. You can even calculate the dimensional formula for magnetic flux. now B निकालें. B का dimensional formula कहाँ से आएगा? बच्चे कहेंगे B लॉ से आएगा. अजी नहीं, सिंपल रिलेशन रखो. F is equal to ILB. Therefore, B is F by I. F कितना हमारे पास? Equal to तो नहीं डालते. MLT minus 2 over IL. तो B की क्या डायमेंशन आ गई हमारे पास? M T minus 2 I minus 1. Therefore, magnetic flux, which is B into A, ये होगा जी ML2T minus 2I minus 1. प्लीज सी कि मैं यहाँ पे गलती भी कर सकता हूँ. चेक कर लेंगे. These are the units for magnetic flux. शुरू में बड़ा मीठा मीठा ही होता है. कोई एप्लीकेशन नहीं, कोई सवाल नहीं, सिर्फ सिंपल प्योर डिस्कशन. लिख लेना, छोड़ना मत. ये सारी जो हमारी कथा है इसे इकट्ठी करके बोल दिया फैराडेज लॉ. फैराडेज लॉज ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन. पहला लॉ ऐसे लिखोगे कि बोर्ड पे लिखो. पहला लॉ हमें कहता है कि whenever there is a change in the magnetic flux linked in the circuit, whenever there is a change in the magnetic flux linked with the circuit, an EMF or a current is induced which lasts for the time the flux is changing. ये इलेक्ट्रोमैग्नेटिक इंडक्शन की डेफिनेशन भी है. अगर कोई पूछे व्हाट इज इलेक्ट्रोमैग्नेटिक इंडक्शन, तो पहला लॉ whenever there is a change. कभी नहीं लिखता था मैं क्लास में, तो बोल देता था, आप लिख लेते थे. whenever there is a change in the magnetic flux, linked with the circuit, an EMF or a current is induced which lasts for the time the flux is changing. ये आज के डिस्कशन की जिस्ट है सारी. और जो फर्स्ट लॉ है ये डेफिनेशन भी है EMI. डेफिनेशन फॉर EMI, इलेक्ट्रोमैग्नेटिक इंडक्शन की डेफिनेशन भी है. दूसरा, the induced EMF, हमने देखा था कि when the magnet is moved towards or away from the coil at a faster or a slower rate, तो वो डिफ्लेक्शन कम ज्यादा हो जाती है, ज्यादा कम, faster slower ज्यादा कम. The induced EMF is directly proportional to the rate of change of magnetic flux. If phi1 is the flux at the time t1, phi2 is the flux at the time t2, तो E इंड्यूस्ड ईएमएफ का E इस तरह डालना चाहिए. अगर बड़ा E डालेंगे वो इलेक्ट्रिक फील्ड होता है, तो इंड्यूस्ड ईएमएफ का E ऐसे डालना है. फिर देखो ऐसे डालना है, प्रोपोर्शनल टू phi2 minus phi1 over t2 minus t1, because the phi2 minus phi1 is the change in flux in a time t2 minus t1. Phi1 was the flux at the time t1 and phi2 is the flux at the time t2. तो change in flux कितनी है? phi2 minus phi1. This has happened in a time t2 minus t1. तो एक सेकंड में कितनी हुई? phi2 minus phi1 upon t2 minus t1. E is proportional or E is proportional to delta phi by delta t. Delta phi is the change in flux in a small time. E is equal to minus delta phi by delta t. और बताता हूं नेगेटिव साइन क्या है. और इन डिफरेंशियल फॉर्म E would be minus d by dt of phi. The negative sign is in accordance with Lenz law. अभी लेंज लॉ आज करवा के जाऊंगा आपको मैं. द नेगेटिव साइन यहां से कितना क्लियर है. अगर फ्लक्स चेंज ना हो, बहुत ज्यादा हो जाए पर चेंज ना हो, तो phi2 equal to phi1, induced EMF 0, EMF 0, current 0. Flux constant, differential for constant is 0. Take the negative sign is in accordance with Lenz's law. अच्छा, मैंने क्या दिमाग में आया था? But I think it's okay if the flux is constant. The induced current note डाल सकते हो. Induced current is I is equal to induced EMF upon total resistance of the circuit. E by R. As we proceed into the subject, things will become obviously more clear. Now we simply come to Lenz's law. It is a very, let me see how much time do I have. मुझे 35 minutes into the lecture please. 10-15 मिनट और पढ़ाऊंगा. Lenz law कहता है the direction of induced current. Interesting है बहुत अच्छा. The direction of induced current is always such so as to oppose the very cause of its production. The direction of induced current is always such so as to oppose the very cause of its production. अभी एग्जांपल देखो, ये मेरे पास एक कॉइल है, यहां पे एक गैल्वेनोमीटर अटैच है। Now remember, ध्यान से बात सुनना, मेरी बात गौर से सुनना। This is the top of the coil, and this is the magnet which is approaching the coil. We know that as we see from above, I'm talking about the current. यार अगर इंड्यूस्ड करंट होगा उसके कारण भी तो मैग्नेटिज्म होता है। करंट को क्या मालूम है ये इंड्यूस्ड है कि बैटरी ने पैदा किया। If there is a current in a coil and as seen from above, the current is in the anti-clockwise sense, तो anti-clockwise sense में है तो वो पोल नॉर्थ पोल है, ठीक है ना। इंडक्शन की बात नहीं कर रहा हूं, I'm just talking about a current। ये इसमें करंट है, इस यहां से देखा ऐसे एंटी क्लॉकवाइज है, तो ये पोल नॉर्थ पोल है, इधर से देखो तो वो ऑब्वियसली क्लॉकवाइज होगा, वो एक साउथ पोल है। और करंट लूप विद अ मैग्नेटिक डाइपोल। So we need to remember that when we observe a loop from above and the current in the loop is in the clockwise sense, तो उस करंट के कारण जो वहां पे मैग्नेटिक पोल बन रहा है वो एक नॉर्थ पोल है। अगर on observing the current in the loop, if it is in the clockwise sense, then वो पोल एक साउथ पोल है, ठीक है जी। करंट के कारण जो पोल होता है ना, जादूगिरी तो कोई हो नहीं रही, कहीं ना कहीं से कुछ एनर्जी है विच इज बीइंग कन्वर्टेड। ये एक नॉर्थ पोल है, थोड़ा सा टाइम लगता है, समझ आ गया तो बहुत अच्छा होगा, नहीं होगा तो ऐसे हो नहीं सकता। नॉर्थ साउथ, इस मैग्नेट को मैं जब ऐसे लाता हूं तो ये रुकता है। क्यों रुकता है? क्योंकि यहां पे जो करंट इंड्यूस होगा व्हेन द मैग्नेट इज मूव्ड टुवर्ड्स द कॉइल, वहां एक करंट इंड्यूस होगा ना। ही सेज करंट इंड्यूस की डायरेक्शन कैसे निकाल सकते हो, थोड़ा इनडायरेक्ट सा ट्रीटमेंट है। ही सेज इट हैज टू अपोज द वेरी कॉज ऑफ इट्स प्रोडक्शन। कॉज ऑफ प्रोडक्शन क्या है? नॉर्थ पोल का नीचे आना। इसको अपोज कौन करेगा? नॉर्थ पोल को अपोज कौन करेगा? नॉर्थ। दिस मीन्स कि ये पक्का है कि द करंट दैट हैज बीन इंड्यूस्ड इन दिस कॉइल ड्यू टू द मोशन ऑफ द नॉर्थ पोल टुवर्ड्स द कॉइल, उस करंट के कारण जो पोलैरिटी बनेगी वो जरूर नॉर्थ ही होगी। बोलोगे ऐसा क्यों? दोबारा बताता हूं। यार अपोज करना है, अब बोलोगे अपोज क्यों करना है? अपोज इसलिए करना है क्योंकि कोई जादूगिरी तो हो नहीं रही। द मोमेंट आई बिगिन टू मूव द मैग्नेट टुवर्ड्स द कॉइल, यहां एक नॉर्थ पोल बन जाता है, नॉर्थ ही बनेगा। अगर नॉर्थ बनेगा तो करंट जरूर एंटी क्लॉकवाइज होगा। ये देखो यहां पे करंट ये इंड्यूस्ड करंट है, and this deflection will be say towards the left, क्योंकि यहां पे कौन सा पोल बना? नॉर्थ बनेगा तो ही अपोज करेगा ना। अपोज करना, अपोज करेगा। द मोमेंट इट इज आई बिगिन टू मूव, यहां आ गया करंट इंड्यूस हो गया। ये वाले नॉर्थ पोल ने उसको आने से रोकना है। आई विल हैव टू डू सम वर्क, against the force of repulsion, and it is this work done, this mechanical energy which is converted to electrical energy. So जादूगरी नहीं हो रही यहाँ पे जनाब। जादूगर भी कहता है हाथ की सफाई है, जादूगर भी कहता है हाथ की सफाई है, कुछ ना कुछ साइंटिफिक होता है वहां पे भी। सो प्लीज सी व्हेन दिस नॉर्थ पोल इज मूव्ड टुवर्ड्स दिस, तो यहाँ पे नॉर्थ ही बनेगा, तो फिर नॉर्थ नहीं अपोज करना है। लुक और करते हैं और करते हैं। ये मैग्नेट है जो, if this magnet is moved away from the coil, इसका परे जाना रोकना है, अपोज करना है। The direction of induced current is always such so as to oppose the very cause of its production. As this magnet is being moved away from the coil, as this magnet is being moved away from the coil, there is a current induced in it. कहना क्या डायरेक्शन हो सकती है? कहते हैं इसको अपोज करना है। इस नॉर्थ पोल को अपोज कौन करेगा? यहाँ पे साउथ बनेगा, अट्रैक्ट करेगा। अपोज हमेशा रिपल्शन नहीं करती। अगर आ रहा है तो कुछ ऐसा पोल बनेगा जो कि आते हुए पोल को रिपेल करे। अगर कोई चीज जा रही है मैग्नेट, तो उसको अपोज कैसे करेगा कि जाती हुई चीज को अट्रैक्ट करे। तो यहाँ पे साउथ बनेगा। आई होप इट इज बेटर नाउ। साउथ बनेगा तो ऑब्वियसली जो साउथ है वो करंट यहाँ पे क्लॉकवाइज, ये डिफ्लेक्शन रिवर्स हो गई। लो और करते हैं, एक आधा और करते हैं। ये अगर आप क्लास में होते तो मैं आपसे पूछता क्या करूं, सर ने तो रट्टा लगाया हो सकता है। लो जी, साउथ पोल को परे लेके जाते हैं। We know that when the magnet is moved away from the coil, a current will be induced. साउथ पोल को परे लेके जाना है, इस चीज को अपोज करना है। मतलब जो इसकी मूवमेंट से यहाँ पे करंट इंड्यूस होगा, उसकी डायरेक्शन कुछ ऐसी होगी दैट इट अपोजेस द साउथ पोल गोइंग अवे। तो कौन सा पोल बनना चाहिए? आई होप एंड आई एम श्योर कि बहुत जनों के रादर सबके माइंड में क्या आएगा? साउथ पोल जा रहा है, रोकना है, नॉर्थ बनेगा। तो नॉर्थ बनेगा तो क्या होगा? करंट एंटी induced current है। The moment the magnet is stopped, ना रहेगा बांस, ना बजेगी बांसुरी, ना रहेगा बांस, ना बजेगी बांसुरी। Because for an induced EMF, for where is the EMF? Somewhere जहां मर्जी बैटरी assume कर सकते हो आप। यहाँ शो तो करंट ही हो रहा है, शो तो सिर्फ इफेक्ट हो रहा है। But if there is an effect, there must be a cause. उस तरह के क्वेश्चंस भी करेंगे। So whenever the magnet, Lenz law says, whenever the magnet is moved towards or away from the coil, an EMF or a current is induced, and the direction of current is given by Lenz's law. Oppose करता है, इसीलिए E is equal to minus delta phi by delta t is something really very important. Now, Lenz law जो है, it is in accordance with the law of conservation of energy. कोई जादूगिरी नहीं हो रही है। Lenz law is in accordance with the law of conservation of energy. Lenz law is in accordance with the law of conservation of energy. क्यों? has to be done to move the magnet towards or away from the coil work has to be done to move the magnet towards or away from the coil against the forces of repulsion. Towards आ रहे तो repulsion होगी, against the forces of repulsion or attraction. It is this work done which is converted to electrical energy. Thus, during electromagnetic induction, the mechanical energy is being converted to electrical energy. Low boys and girls, I think that is all for today. That is all for today. This is the basics of electromagnetic induction, where we have introduced to you Faraday's experiments, Faraday laws, and Lenz law. Electromagnetic induction, we will do its basics for 3 days. कुछ तो कवर होगा. प्लीज सी कि आधा घंटा लगा के ये लेक्चर देख लो और नोट्स बना लो, पढ़ लेंगे. We are into our first grand test, please. Bye bye.